In this video we're going to try and locate all the max, min and saddle points of this surface. So to do this, well, remember, if you're truly at a local max, if you slice it in the x direction, then f of x, the gradient right at the top, will be 0. If you slice it in the y direction, so if you slice it in the y direction, then the gradient at the top equals 0. So we're trying to identify fx equals 0, fy equals 0. We're trying to find points on the xy plane, such that f of x equals 0, f of y equals 0. So from this, find fx. So differentiate, take the partial derivative of this whole thing, with respect to x. So so here you've got two blocks, 1, 2. This is just a constant if you're doing it with respect to x. So it's just a matter of differentiating this. This will be 2x, and then this stays the same. And then differentiate this with respect to y. So here you've got two blocks. You've got to use the product rule. So differentiate the first, leave the second alone. That will then give you this. And then plus, leave the first alone, differentiate the second. Differentiate the second will give you 2y. Leave the first alone. So that, well, using the product rule, that will then give you this. So now we've got fx and fy. So we want to find x and y such that both of these equal 0 simultaneously. So so set this to be 0 and set this to be 0. So we are looking for x and y, values of x and y such that both of these equal 0 simultaneously. So let's look at the first one. This thing here can never be below 0. This thing here can never be 0 or below 0. So for this whole thing to be 0, it must mean that x must be 0. So x equals 0 is anywhere along here. So so in order for you to satisfy x equals 0, fy equals 0, you must lie somewhere on this vertical line here. You must, because anything that lies on this vertical line will imply that this equals 0. Okay, so we know it must lie on this line. So now let's look at this thing here. Hang on. So when you set this to be 0, and then you can tidy this whole thing up, because this is in common, so you can factor it out. So that will then take you to here. Okay, you're trying to find x and y such that this whole thing equals 0. This whole thing equals 0. Well, this thing here can never be 0, so concentrate on making this to be 0. Just concentrate on making this 0. If you can make this to be 0, then the whole thing will automatically be 0. Okay, so concentrating on making this to be 0 is really you trying to make, well, if you and also remember, x, we know that x must be 0 because it has to lie on this line because of this bit here. So so we can put 0 into the x. So this thing here will then become this. So now now you can see that y must be 0 or y must be 2. So that means, well, don't forget, from this, anything that lies on this vertical line will satisfy this, and then anything that's 0 and 2, 0 and 2. So so we must know that at these 2 points, at 0, 0 and at 0, 2, then both of these will be satisfied simultaneously. Okay, so we must know there's something fishy going on at these 2 points, but we don't know if it's a local max, a local min, or a saddle. We've got to do more tests. Okay, so let's consider this point now. Let's consider 0, 2. So let's investigate 0, 2. So let's investigate 0, 2. So to investigate 0, 2, let's look at the concavity at 0, 2. So from this, differentiated again, this then would tell us the concavity, or evaluate it at 0, 2. So that means put this into the x, there's no x in here, so forget about it. Put this into the y, so that then becomes 2e minus 2, tidy this up, that will then give you this. So this thing here will always be greater than 0. This thing here will always be greater than 0. So we suspect that it's well, this thing here is bigger than 0, so we know it's going to concave up. It's going to concave up. Well, if it concaves up, then we have a hunch that we suspect that it's a local min. We are at the lowest point because everything is concaving upwards. Everything. This tells us the concavity, and everything's concaving up. So we suspect it's a local min. So we suspect it's a local min. But remember, it's not. This is not sufficient enough. We have to do an extra piece of information. We have to perform an extra piece of the test in order to confirm that it is truly a local min. At the moment, we just suspect it's a local min. So we need to compute this value here. Okay. So we need to perform the second part of the second derivative test. So I will continue in the next video. Okay.